you can take it away. Perfect.
Okay, hello everybody, and welcome to the ThermoSig report that I present on behalf of other ThermoSig members that are listed on this slide. Jasper van Batten, the co-leader of ThermoSig, Klaus Müller from University of Cape Town, and Richard Szczepanski from KBC, both experts in thermodynamics and members of ThermoSig over many years. And finally, Kyle Abrahams, our Chief Technology Officer. The special interest group thermodynamics is a CO-Lan unit with the task to develop, maintain, and promote thermodynamic interface specification, and its active member are repeated here on this slide. Our main goal this year was the completion of the compliancy test specification for thermodynamic interfaces, and that was a big task requiring much effort, so that we have accomplished it organizing 2 hours weekly online meetings for detailed discussion, and also much work has been done offline, mainly by Kyle and Jasper, for preparation of documents and coordination with the test suite. Now to the scope of ThermoSig. The current list of the documents within the scope is listed on this slide, and it includes thermodynamics interface specification version 1.0 that is deprecated over many years, and we suggest to remove it from the charter, as will be explained later. The thermodynamic interface specification version 1.1 is our main working document. We are trying to steadily improve it, and the COBIA version of thermodynamic interface specification, also called as 1.2, is available but not yet published. The custom data interface is a common interface that could be used for many various purposes in CAPE-OPEN environment, for temporary storage of intermediate results. Still, interaction between property package and PME seems to be the main usage of this custom data interface, and of that reason it belongs to the scope of ThermoSig. Chemical reaction and compound server are the 2 other interfaces that are also maintained by the ThermoSig, and additionally there exist numerous related documents, files, tools, software that fall in the scope of ThermoSig. Our key responsibilities are listed on this slide, and they include first to maintain and manage active interface specification. The main 2 points here are to provide revisions to improve usability and performance, mainly based on the user feedback, as well as to provide errata and clarification and to integrate them in main specification document. Our second key responsibility is to assess and prioritize on extension. Second point is to help CO-Lan members in development of their implementation of thermodynamic interfaces. In turn, this includes advices on how to migrate from older to the newest interface specification, how to migrate from COM to COBIA, and how to implement particular thermodynamic interfaces. Last not least, after the CO-Lan decided to develop the certification suite, the ThermoSig is also responsible now for definition of compliancy test for thermodynamic interface specification. Well, now back to the issue with deprecation of version 1.0 interface specification. This issue has been discussed already 7 years ago on our annual meeting, and since 2018, CO-Lan provides no further support for this specification. Since the development of the currently active thermodynamic specification version 1.1, CO-Lan is always encouraging all software developers to migrate and to use this version. And of this reason, we decided that it is now the time to close this chapter and to remove this version from our chapter. Still, we have to keep the binary libraries as a part of 1.1 library installer for backward compatibility. Well, now to the summary of our activities in this year. First, we completed the chemical reaction interface specification. Some more details will be given on the next slide, but our main goal this year was the fulfillment of definition of compliancy test. In particular, we have completed the property package testing specification and delivered it for implementation in the test suite. This specification covers all interfaces defined for the property package, except common interfaces which fall into the MNT SIG responsibility. Furthermore, we have completed the specification of a material object, of a specialized material object needed for testing of unit operation. And during the work on the specification, on the definition of this compliancy test, we have realized that many statements in the definition or in the description of distinct methods are ambiguous and not applicable for certification purposes. Of this reason, numerous errata and clarification have been made, and these clarifications have been made nearly for all thermodynamic interfaces, and to simplify handling of that documents, each interface has now its own END document, and one of our next goals will be to incorporate all this errata and clarification document in the main documentation set. Now, some more details about chemical reaction interface. This document has already been prepared last year, but some required references to the manager common interface specification were missing because the manager interface specification was not published. In the meantime, this specification has been published, and the document is now available from the CO-Lan website, and the appropriate IDL is currently in preparation. This allowed us to incorporate the required references into the revised chemical reaction interface document. In particular, the section of use cases has been updated and reorganized to improve readability. And now the interface specification has been submitted for a second RFC. And as soon as we will get a response to the request for comments, the final version, the final document will be prepared and published on the CO-Lan website, and the appropriate IDL will be prepared based on the COBIA route as has been explained by Jasper in his COBIA presentation. Well, now let's go to the certification support. Our goal here was to prepare a full set of test definitions for all thermodynamic routines. Definition of the test specifications themselves was probably not the most laborious task. It was much more difficult to clarify and adopt the description of methods to make them testable. And of this reason, preparation of test specification went always hand in hand with errata and clarification. Here on this slide, you see our roadmap metrics that was presented already last year. To understand these metrics, it is important to realize that there exist 4 common scenarios relevant for the certification and involving thermodynamic calculations. In the first row, you see the 2 cases where the specially adopted PME test PME is used to test external PMCs, either property package left or a unit operation. In the second row, you see the opposite situation where the specially adopted PMCs, either property package test PP or unit operation test unit, are used to validate the PME implementation. The left column is much more simpler, as it involves only 2 players, a PME and a property package, whereas in the right columns there are 3 players, a unit, a PME, and a property package. Even if we are interested here only more or less in the interaction between the unit and the PME, the property package still remains important here, as the PME in many cases just forwards the calls from the unit to the property package. Well, the 2 cells in this matrix in blue has already been addressed to last year, and this year we just made some corrections there and completed the definitions of tests, whereas the 2 other cases in yellow has been fully treated this year. We have started with the testing of property package. This is perhaps the most important case for the property package vendors, and of this reason that was in initial focus by CO-Lan. In this case, the test engine controls all thermodynamics calls, and what is more important, it provides a specially adopted material object that is capable to validate or to check all actions made by the property package on the material object, thus allowing to validate the correctness of property package operation. After we have finished with that step, we could address our attention to the second case, where the test specially adopted unit is used, just a moment, is used to test the PME implementation, and in this case, test unit controls the thermodynamic calls. And this case is in fact very similar to the previous one, and only minor modifications were needed. Just keeping in mind that now the PME serves as a thermodynamic server for the unit and validates all the calls coming from the PMC. Now let's address our attention to the opposite traffic. First, let's consider the case where a specially adopted test PME is used to test an external unit. In this case, the test PME receives the thermodynamic calls, validates their correctness, and provides a material object. After we have finished with this case, we could address the last work package, where a test PMC, in this case property package, was used for testing the PME implementation. And this case again is very similar to the previous one, except that the property package is the actual thermodynamic server that receives the thermodynamic calls and validates its correctness. As I already mentioned, numerous errata and clarification have been made during preparation of these test definitions for the certification suite. And this A and C cannot be released without additional request for comments, and taking into account that test suite and E and C documents are interdependent, and moreover that this errata and clarification has been made to ensure the testability of thermodynamic standards. It becomes clear that the release of the beta version of our test suite has to go hand in hand with the RFC for the prepared errata and clarifications. And the separate presentation by Malcolm Woodman will give some more details on this issue. And now another big issue in this concern is now how to integrate this numerous errata and clarification into the main document, especially keeping in mind that the consistency within the document and between the documents have to be ensured. And it was decided to postpone this step until the common source CAPE-OPEN documentation standard will be designed and approved, and a separate, as already was mentioned by Diaspora in his presentation, and a separate presentation by Kyle will bring light to this topic. At the beginning of my presentation, I have mentioned that old draft of the so-called compound server interface also belongs to the scope of Thermo SIG. It has been realized long ago that the existing physical property database interface is just too over-complicated if only pure compound data are required. On the other side, it was also realized that ICAPE Thermo Compound Interface version 1.1 would potentially suffice for that purpose to retrieve information about pure compound properties, but it doesn't provide functional description as well as no validity range for the T and P dependent properties are available there, and mixture model parameters are not accessible for that interface. Honeywell has proposed a simpler design, which was adopted by the Thermo SIG, and in 2011 we have prepared a draft document for initial compound database component, which had to implement compound server behavior. This means ICAPE Thermo Compound implementation, interface implementation, as well as compound correlation servers interface, which would allow to access the parameters of pure model correlation as well as their validity range. This proposal was not did not cover the mixture data because it was decided that such an option would not be useful in the CAPE-OPEN landscape. As Honeywell was not longer actively participating in CO-Lan and no other member showed interest in such a proposal, it was shelved. In our recent discussion, we have agreed that exposing of functional description for model correlation would be first too complicated and second would not follow the CAPE-OPEN idea, access properties and not the models and their parameters. Furthermore, we have confirmed that access to binary to mixture models, for example, to binary interaction coefficient is neither desired nor needed. And of this reason, as already mentioned, the compound server ICAPE thermo compound interface would really suffice for many purposes in practical usage. However, the validity range of T and P dependent properties is not available there, and this could be useful for many practical applications. And of that reason, we have decided to make a very short proposal and discuss it with you, whether or not to follow this idea. To develop one more primary PMC, the compound server component, which would simply implement 4 interfaces: ICAPE identification, ICAPE utilities, the standard ICAPE thermo compound interface from version 1.1 specification, and one additional new interface, ICAPE thermo compounds 2, that would just allow to access the validity range for pure compounds models and perhaps potentially also the uncertainties of the models defined on the property package. So now questions to the CAPE-OPEN community. Is there certain interest for such a component in the current CAPE-OPEN environment, and should Thermo SIG make a revised and simplified proposal, or should we simply drop this old draft from the charter and add the missing interface routine first in the new version 2.0 thermodynamic interface specification later? Well, now I'm at the end of my presentation, and here you see the outlook for the coming year. First, we will continue support for the certification process, mainly with the goal to provide feedback for certification implementation. And we presume that there will be a need for further maintenance of existing interface specification to resolve issues coming from the certification process. Furthermore, we are going to publish the chemical reaction interface specification and the corresponding IDL as soon as possible. And our next goal will be to participate on the development of the new structure for the common source CAPE-OPEN document standard, and depending on the progress in this in the design of a common source document, we are willing to start to integrate our numerous errata and clarification into the main documentation. So that's all from my side. Thank you very much for your attention, and I will be happy to answer your question, but probably to initiate at least a very short discussion before the lunch. Please try to give us some response to the question addressed to you about the future of compound server component. Thank you.
Thank you. Any questions for Sergej? I think everybody's hungry for lunch, Sergej. I put you at a very awkward slot. I see there are one or two questions in the chat maybe that we can handle. I see one question from Harry. Let's take that one.
Yeah, this new component server, is that meant to be for all components and all the time? Because it could make calculations a lot slower if you're gonna do propagation of certainties and all that stuff. So I really like the idea.
Well, I suppose if you are really developing as a complex property package, or you are developing a PME, then very likely you will have internal means for some simple regression for fitting parameters of your own native models for pure compound correlation. This means for me that you could simply request from this component, compound server component, a series of points in the temperature range of interest, and to refit them to get your native models. At least that would be a procedure for me.
Mm-hmm.
In terms of concept, it would be a binary interface to your pure component database.
Yeah, I like the proposal. Don't get me wrong. I'm just worried about just like any other standards and add-ons and so on, that we keep focus on calculation speed. That's the only thing.
Well, that's the point. We had several very complicated database interfaces in the past, which essentially nobody implemented because it was too complex. And then there was a proposal on the table which was still on the complex side. We're thinking that if we simplify it to the point where we can get just enough information from it to get us started, we might stand a chance to actually pull this off.
Yep.
Yeah.
Yep. Okay. Good. Thanks.
It should be a binary interface, Jasper. What you said?
A minor interface. Come again?
Did you say it was a binary interface? Or?
Well, we just really want a primary PMC that has iCAPE thermal compounds on it, and we're wondering what we're missing there. Just iCAPE thermal compounds, nothing else.
What happens when you don't have that information? Which is very clear.
Then don't write software components. But I'm not sure of the question.
I can't hear the question, but I hope I show the right picture.
Yes, that's the picture. So it is not supposed to give you any mixture data, just what you have in the pure components. And
But you may not have it on pure components as well.
Sorry, so come in.
You may not have that information on pure components as well.
But as with most CAPE-OPEN implementations, there is a definition of standard elements of information that you might have. But nobody has all of that elements. You can pick and choose what you expose.
Okay.
If you have critical temperature, you expose critical temperature. If you don't have a centric factor, you don't expose a centric factor.
Right. I think if there are any more questions and discussions, please feel free to join the Thermo SIGs that take place on Thursday mornings. You can either reach out to myself.
Tuesday.
Tuesday mornings. You're right. Either reach out to myself or to Sergej. And you're welcome to join those sessions as well.
Exactly.
Right, we will break off now for lunch. We are a little bit behind schedule, so we'll pick up again shortly after 1:30.